Welcome to another video demonstration in Weiss Software's VisualCAM Stencil Design series. In this demonstration, I'm going to show you how to identify the shapes in your design using package definitions. There are currently 1,350 part definitions included in the packagedefs.csv file. To enhance the list, please contact support@wssi.com for more details. Once all footprints have been identified, I will generate a stencil for the design. So let's get started. Before we begin though, there are some things that must be completed before running the Identify Parts command. First, for this particular demonstration, I will need a design with a top and/or bottom layer or original paste layer, and this must be open in the workspace, or it must be imported. Second, before you begin any processing, go to the User menu and run the macro called Stencil Layer Prep on your original top and/or bottom layers. This macro automates 3 processes on the layer you specified to prepare your data for optimal processing and identification. These are drawn pad conversion, stacked pads removal, and custom apertures to intrinsic apertures conversion. Now that I am ready to begin, I go to the Stencils menu and select the Identify Parts using Package Definitions command. You can also access this command using the ID Parts Use Package Definitions button located on the Stencil toolbar. When the Part Identification Package Definitions dialog box opens, the first thing you'll notice is that VisualCAM has chosen the top layers automatically. This is because the top layer in my design was assigned prior to running the command. If the layer types are not set up, use the drop-down menu to choose a layer to use as the original layer. If no bottom or silkscreen layer types exist in the design, the field will list none. The modified layers are where the paste data will be generated. You can either select a layer to which you want this data to be generated, or leave it set to none, and VisualCAM will automatically select the next available empty layer when generating the paste data. Choose the Run 2-Pin Part Orientation check option if you have a design with ambiguous 2-pin part orientation. VisualCAM will prompt you to approve the orientation of pads that could match either vertically or horizontally. If you have a silkscreen layer with well-defined part outlines, choose the Use Silkscreen Layers to verify 2-pin part orientation option, and the system will use that data to determine the component orientation. Note that this option only becomes available when you first choose the Run 2-pin part orientation check option. Next, the tolerance is set to account for small variances between part instances and for misalignment in a row of pins during the pin identification process. In this case, I am using 0.0002 as the tolerance. The Report Unidentified Pads option is used to run the unidentified pad check after the identification process is complete. You can either run this during the identification process, or it can be run separately after you have identified all footprints. I am not going to select this because I will run this after the process is complete. If you want to deselect any of the default package definitions, click on the Select Packages button to access the dialog box. In the Select Packages dialog box, remove the checkmark from any packages you do not want included during the identification process and click on the OK button to continue. Back in the Part Identification Package Definitions dialog box, click OK to start the identification process. The packages are processed in descending pin count order. Packages with the same number of pins are processed in descending physical size order. Note that a package definition is created for each possible pin count in the definitions file. This may result in multiple definitions for a single definition line in the file. The prompt line will display the total number of package definitions created from the definitions file and a progress gauge that will show the process progress. Once package identification is complete, you will receive a message stating how many part instances were found. Click on the OK button and continue on to the next step. To find out if all of my parts have been identified, I go to the Analysis menu and select the Find NonPart Pads command. You can also access this command using the Find NonPart Pads button located on the Stencils toolbar. A part identification dialog box will appear letting you know how many non-part pads were found. Click on the OK button to continue. Any errors will be listed in the navigator on the Analysis tab under Paste Non-Part Pads. When you open the folder and click on the first error, it will be highlighted in the main window. You can use the arrow keys on your keyboard to cycle through any errors. If you do find any remaining parts in your design that have not been identified by this automatic process, refer to the video demonstration in this series describing how to identify parts by selecting the footprint. Once the new parts are identified, shapes should be assigned to them. For detailed information about assigning shapes and adding them to the footprint library, refer to the video demonstration in the series describing how to use the Stencil Footprint Shape Library dialog box. We recommend that as you work with VisualCAM, you create a master footprint library with paste shapes assigned that may be used with all designs that you work with. Over time, this library will grow to include most parts that you encounter, and new parts can be added to the library whenever they are found. Once the master library is established, it is loaded into each design. Once all the parts have been identified and shapes assigned to the parts, I am ready to generate the stencil. To generate the stencil, I go to the Stencils menu and choose the Generate command. This command can also be accessed using the Generate Paste Layer button on the Stencils toolbar. In the Stencil Generation dialog box, VisualCAM defaults to the current shape set. Any shape sets included in the design may be selected by dropping down the list and choosing another one. Select the layer or layers for which paste is to be generated. In this design, I only have a top layer, so that is the only one selected and active. When the No Shape is defined, Use Unmodified Shape option is checked. All footprint pins that do not have a shape assigned in the current paste shape set, use the part pin as the paste shape. Effectively, this is the same as assigning a paste shape of original with no modifications to the pin. When the Update Existing Paste Layer Data option is checked, and there is data on the paste layer at the location of a part, the existing data is deleted and the new paste shape is added. If it is not checked, the existing data will remain and new data will not be generated. Using the reference layer of the dialog box is optional. The reference layer would be used if you make a copy of the original data onto a new layer prior to starting up the stencil generation. The reference layer allows you to easily see when all paste data has been generated by removing the data from the reference layer until the layer is empty. This is commonly used when you have a large design or you are working from a copper layer that has traces, and this method allows for quick visual verification that you have generated paste shapes for all pads. Reference layers should be layer type Other. If you do use the Delete Reference Pads During Generation option, at least one reference layer must be specified. Pads on the reference layer at the location of a pin for which paste data is generated will be deleted. When you have chosen all your options, click on the OK button to run the command. Once VisualCAM is finished generating the paste layer, I want to visually verify that the paste shapes are correct and complete. To do this, make sure the pads on the new paste layer are of a contrasting color to those on the original layers by using the Colors bar and making changes if necessary. With both the original and paste layers on, you can either use the View Overlay command or in the Colors bar, double-click on the paste layer to bring it to the top. This will allow you to visually see the new paste shape and the original shape. For those who like keyboard shortcuts, you can turn on the View Overlay mode by pressing Ctrl-T on your keyboard. If you need to make any changes to any of the paste shapes, go to the Stencil Footprint Shape Library dialog box. You can use the menus or the Stencil toolbar button to access the library, or you can right-click on a part in question and choose Open Footprint Shape Library from the list of options. Make any necessary changes and then rerun the stencil generation. Once the footprint identification and stencil generation are complete, save the VCAM file. Note that when you save the VCAM file, the shape set and the footprint library are saved in the file as well. If you do not save the footprint library .fpl or shapeset.shp files separately, you can always go back and open the VCAM design file and save these files from within the footprint shape library. This completes the Identify Footprints by using package definitions and generating a solder paste stencil from Weiss Software's VisualCAM Stencil Design series.